Let's go. Yo. We are going to learn center of gravity and its limitation. Center of gravity is a theoretical point in the body where total body's weight is thought to be concentrated. And it is important because it predicts the behavior of moving body when acted by the gravity. And it can be defined in a way where a point is marked where the weight of an object is balanced in all the directions. Its position is a plays a key factor in it because it balances all the forces across it, and it is applied in various real life places such as buildings, vehicle stability, aircraft design, and structural design, and whatnot. And to calculate the center of gravity, we generally sum the moment of each individual part of an object around a chosen interface point, and the formula is m1 into r1 summation of divided by summation of mi. And there are some softwares which are used in calculating center of gravity, which can simplify and automate the process of calculating center of gravity. The factors affecting center of gravity are the weight distribution, as uneven weight distribution of weight can shift the center of gravity. The shape of an object can affect where center of gravity is located, and the density. And if the density of the material used is different at different places, it can also influence the center of gravity. Applications of center of gravity. It's used in ensuring the stability of the buildings and bridges, designing cars and aeroplanes to minimize the risk of tipping over when they are at relatively high speed, and improving balance and performance in sports like gymnastics and skiing. Limitations of center of gravity. This is a dynamic system where a moving car or a spinning object can change over time. And if an object consists of non uniform density, objects in their center of gravity cannot be easily calculated. And the complex shapes, it's a headache to find the center of gravity of complex shapes. And here we come to the questions. Here is a question given about a solid cone having a diameter of 150 mil. Let me zoom in. A solid cone having a diameter of 150 millimeter and height of 150 millimeter is placed on the top of a cylinder of diameter 150 millimeter and height 200 meters such that axes are collinear. So locate the center of gravity. So we tend to divide both figures into 2D perspective so that the calculations get easier, and we find volume of figure 1, which is pi r square h, which yields the respective answer, and figure of volume of figure 2, which is a cone whose formula is 1 by 3 pi r square h, which yields respective answer. And later we find x dash. But before that, we need to find center of gravity of respective bodies. Center of gravity of respective bodies can be calculated by simply locating the center. For example, it's a cylinder, and it we presume it to be rectangle due to which the center of gravity lies at 75, 100 and above as triangle, and the center of gravity lies at h by 4 from the base of the triangle. Hence, the respective center of gravities are found out. Then we use the formula x bar is equal to summation of vx divided by summation of v, which is nothing but volume multiplied into center divided by sum of volumes, and we get the answer to be 75 and 127.5. And here we come to next problem. Finding the area of triangle cut out from the rectangle. Means this is a formula where we do reverse engineering. Basically, just reversing the steps. Instead of finding, we'll subtract it, and we'll divide the figure. First, no, we'll divide the figure in the respective manner. First, we'll find the area of rectangle, which is 1 into 1 is 1 meter square, and area of triangle. And we take assumptions that center of gravity lies at a distance of h from the base, and The center of triangle lies at a distance of x bar from x-axis and y bar from y-axis. And area of the triangle is found to be h by 2 meter square, and center is found to be zero point 0.5 meter, and similarly y2 is found to be h by 3, as we learned in the previous step that center of gravity of a triangle lies from h by 3 from the base. And after that we do reverse engineering, hence we use negative sign, that is a1 y1 minus a2 y2 divided by a1 minus a2. And as we assumed y bar to be h, we tend to use y bar is equal to h at this point. And we solve the respective equation, and it turns out to be quadratic equation. And after solving those values, we get two respective answers, which is 2.37 meters and 0.634 meters. 2.37 meters is not possible because the overall length of the square is 1 meter. Hence, we'll neglect that answer and we'll go with 0.634 meter. And we find the area of triangle to be half into 0.634 into 1, which is nothing but 0.317 meter square. And that's it.